Hey guys, hopefully your exams have been going well so far. This is just a little help question on optimization. It's got one little trick in it you need to remember. Once we get that out of the way, it'll all make sense and you'll have no problems with it. Let's go and have a look at what that trick is. So, we need to find the number of blankets that should be produced per day to maximize the total profit. So I'm just going to define that total profit as P of X. So let total profit equal P of X. And what will P of X be equal to is the next thing. Well, your profit and total profit is going to be your total income minus your total costs. So what does that look like? Well, the total costs we're given, the total cost of producing X blankets per day is that amount there. So that is a quarter X squared. I'm just going to write it as X squared over 4. I prefer it that way. It doesn't matter though. Plus 8X plus 20. And that's in dollars. Now here our total income, if we read carefully, and for this production level, each blanket may be sold for 23 minus half X dollars. So the total income, I'm going to sell X blankets, and each of them I'm going to receive 23, take a half X, so X over $2. So that's my total income there. And that's really the only trick with these ones. Sometimes these ones are a little bit tricky. They give you the total cost, then they give you the profit per item or the sale price per item. So you just need to remember to multiply by the number of items, and then it all makes sense. Let's expand and simplify this. I'm going to have 23X, take X squared over 2, minus X squared over 4, take 8X, take 20, make that look pretty. I'm missing a half and another quarter, so that's negative 3/4 of X squared, so negative 3X squared over 4. I'm going to have 23X here, subtract 8X, so that is plus 15X. And finally I've got the minus 20 on its own. So this is all P of X. Let's go in and fill that in. Keep our working nice and easy to follow. Remember, the easier you make your working to follow, the more likely it is you're going to be rewarded in the exam by the marker. They're going to be really happy when they see that it's really easy to follow what you're doing. Alright, now we want to try and maximize this. So to maximize it, we're going to find the derivative, let the derivative equal 0. So let's go ahead and find P dash of X. And when I multiply this by 2, I'm going to have negative 3X over 2 plus 15. For a critical value, not necessarily a maximum, but for a critical value, let P dash of X equal 0, negative 3 over 2 X plus 15 equals 0. Continue way up the top here. So obviously that 2 is really annoying. I could multiply by negative 2/3 all at once, but let's not get too fancy. So I'm going to have negative 3X. I'm just going to multiply by 2 plus 30 equals 0. You can see the answer from here now. X equals 10. You're done. You've got the answer. You should really check it is a maximum. Is it a maximum? First derivative test, check the derivative just before 10, just after 10, and look at the shape. That's one way you could go. If I did that, the derivative just before 10, so at 8, negative 24 over 2, negative 12 would be positive. So P dash of X, which is less than 10, it's going to be positive. P dash at 10 is 0, and P dash at an X value greater than 10, you could call that 10 plus delta X or something. That might be a nice way of doing it. Is going to be negative, and we can see that if I put in 11 there, I'm going to have negative 16, negative 15 and a half, plus 15 instead of being negative. So that would work. Or what's your other way of checking if it's a maximum? Let's do the second derivative. The second derivative is negative 3 over 2. Therefore, I have a local maximum. because I know that my gradient is going to be decreasing. So first derivative 0, second derivative decreasing, must be a local maximum. Alright, I hope that helps. Keep up the good work. I'll expect a few more questions now that some of you have got some out of the way. Good luck with everything that you're doing in the meantime. See you then, guys.